Hello friends, my name is Smith Kumar Mehta, and we are doing the problem related to Annova test today. Here three training methods data related to three training methods are given, and the question is asked to perform the analysis of variance to test at the 0.05 level of significance whether the three training methods lead to different level of productivity or not. So for the first step we have testing of hypothesis. In testing of hypothesis we have null hypothesis, that is as not. In this we assume mu1 equals to mu2 equals to mu3, that is mean of all three methods are same. An alternative hypothesis, that is just opposite of as not, that is not all means are same. So we have three methods, so k equals to 3. And step 2, we have step 2, that is level of significance alpha equal to 0.05 as it is given in the question. Now step 3, calculation. We need calculation, and in calculation we have a separate table. In this table we have to put the data from the given data as x1, x2, x3, and we have to do some calculation, that is x1 minus x1 bar whole square, x2 minus x2 bar whole square, and x3 minus, this is our table. Here n1 equals to 6, and summation of x1, this whole 6 data is 240, and x bar, that is summation of x1 minus n1 equal to 45. Now we have to do is 45 minus 45 whole square equal to 0, 40 minus 45 whole square is equal to 25, 50 minus 45 whole square is equal to 25, 39 minus 45 whole square is equal to 36, 52 minus 45 whole square equals to 49, and 44 minus 45 whole square is equal to 1. Now we have to do summation of x minus x1 bar, that is equals to, we have to calculate this whole data, that is 136. Similarly we do the further calculation of for x2, x3. Similarly after calculation we get these values. Now our next step is to we have to find the combined mean of this data. I hope you know the formula of combined mean, that is combined mean x bar equals to n1 x1 bar plus n2 x2 bar plus n3 x3 bar by n1 plus n2 plus n3. We have given n1 is equal to 6 x bar into 45 plus 6 into 48 plus 6 into 42 by 6 plus 6 plus 6, that is equals to 45. Now we have to calculate the SST, that is sum of square of treatment, and SSE equals to, that is sum of square of errors. For calculation of SST we have to write like n1 equals to something, n2, n3, x1 bar, x2 bar, x3 bar, now and also x bar. We have this value in the table, and the formula for SST equals to SST is n1 times x1 bar minus x bar square plus n2 times x2 bar minus x2 bar minus x bar square plus n3 times x3 bar minus x bar whole square. We get the values like 0 plus 54 plus 54 equals to 108. And for SSE, that is sum of square of errors, we have in this table we get the values like this. These values, summation of this 136 238, 140, 140, summation of this table, this row, we get this value is equal to 136 plus 238 plus 140 equals to 514. We need this value in Annova table. Now we have to draw Annova table. That Annova table is, it has some columns like source of variance, degree of freedom, sum of squares, mean sum of square, mean sum of squares, and this column is for F calculation. And here in this row we have treatment and error. Now we are going to do the calculations. Here degree of freedom, k minus 1 equals to 2, n minus k equals to 15. Here n equals to n1 plus n2 plus n3 equals to 18. So n minus k equal to 15. We had k equal to 3. So sum of squares we have already calculated. Sum of squares of SST, sum of square of treatment equals to 108, and sum of squares of error equals to 514. We here have mean sum of square. Mean sum of square of treatment equals to, we have formula, mean sum of square of treatment equals to SST by k minus 1. So we have SST equals to 108, k minus 1 is equal to 2, that is 54. So MST equal to 54. We have MSE. Here we have to calculate MSE. The formula for MSE is SSE divided by n minus k, that is 514 divided by n minus k is equal to 15. That gives value 34.267. 34.267. Now for F calculation, F calculated equals to we have formula MST by MSE, that is 1.575. Now we have step 4, and step 4 is tabulated value and their graphs. We have tabulated value, we have to calculate. We have formula F tab equals to, we have order F numerator comma F denominator, where numerator is treatment and denominator is error. So we have F equals to k minus 1 comma n minus k, that is F2 comma 15. From table we get the value of F2 comma 15 equals to 3.6823. Now we have to draw graph equal to tabulated values, that is we have to draw graph like asymptotically. Here we have value 3.6823. Let us take the value 3.2 here, 3.6823. For this part we reject the value, and for this part we accept the value. We have calculated the F calculation, that is 1.575. That comes here, this side, 1.575. This comes on the acceptance region. So our this comes under accepted region. So our null hypothesis we assumed was correct. That is, we come to step 5. This is conclusion, that is in this step we have decision.